Hello and welcome back. Today we begin the first of several weeks of studying categorical logic. Categorical logic is a system developed by Aristotle, and it's a powerful logical tool. It is a system of deductive logic. So now that you've had the opportunity to study in general what an argument is, and then more specifically what an inductive argument is, how it succeeds or fails, and then what a deductive argument is and how it succeeds or fails, we can now hone in on the deductive side of our course. We begin with categorical logic, which is a system of logic that will give us some really great skills. These skills include learning a system of testing an argument for validity, as well as learning how to pay attention to the logical structure of our language. So this will become more clear as we go forward, but let me at least just say this. One of the really interesting things about what Aristotle does is he takes all statements, so that is any sentence that's true or false, and he resolves it into one of four categorical proposition types. So what we'll be doing is looking at these four categorical proposition types, what their structures are, as well as what inferences we can make within and among them. So to that end, we start with individual sentences and drawing what are called immediate inferences from one proposition to another. And then we'll move on to the categorical syllogism, which is comprised of three categorical propositions. We will learn techniques for organizing and testing these syllogisms for validity. Now, I mentioned that you'll be developing some really strong skills. These are skills that are both directly relevant to how you can carefully read and analyze any argument, even if it's not in the categorical form, but also will allow you to be more efficient in the ways that you read any text. In other words, I think part of the benefit of doing this work is you're being able to look at language in a new way, that is, as a logical structure, not just as a sentence with meaning or connotation. So let's go ahead and get started on categorical logic. Remember, we're going to spend a little bit of time looking at categorical propositions themselves and how you can draw immediate inferences from one categorical proposition to another. And then we'll move on to talking about and studying the categorical syllogism and learning ways that we can determine that syllogism's validity or invalidity. Let's get started. So we're about to embark on one of two systems of logic that we study in preparation for more intensive and specialized study of formal logic, which is what we call deductive argumentation. And the way that we're going to proceed is as follows. We're going to be laying out a lot of technical terminology and a lot of pieces of a larger system that Aristotle developed. So bear in mind that some of what we're going to say is going to be, I hope, understandable, but we won't be doing anything with these concepts right away. In other words, some of what we're saying is provisional. You want to understand certain technical concepts, and then we'll begin to put those concepts together when it's time to start building specific skills. So basically, in section A and B, we're laying out technical terminology, and we're making some basic sense of what what the foundation of Aristotle's system is. And then we'll move on to developing skills in C and D, in section C and D. And then we'll continue in section E and F to lay out further technical concepts that offer us a different way of looking at categorical logic. So we'll end up focusing most of our attention at the beginning on what's known as Aristotelian logic, and then we will move forward to what's known as the modern interpretation. And then when we're done with chapter 5 and we move into chapter 6, we will focus again on Aristotelian logic and then move on to the modern interpretation of the system known as the categorical syllogism, or the system that supports our work on the categorical syllogism. So with that in mind, just remember we're laying out pieces and not all of it may cohere well at first, but then I'll make sure that I spend time working through quite a few examples, and I'll do that in a separate video. Okay, so first off, we are looking at a system, we will look at a system that Aristotle developed. And one of the questions that we can ask is, why did Aristotle develop this system as opposed to, let's say, the propositional logic system, some of which we'll learn in chapter 7 and chapter 8? Well, the short story is that Aristotle is interested in how to demonstrate certain truths that he wants or that we assert about the world around us. And he thinks that when we look at any claim type, and you already know what I mean by that because you've looked at arguments, you know that an argument is a statement that, or sorry, an argument is consists of statements that are either true or false, and those statements bear an inferential relationship to each other. For Aristotle, these statements are going to be statements about things in the world and the way that nature is. So what he wants to do then is to take any sentence that is a candidate for an argument and conform it to a particular structure. So for Aristotle, there are 4 types of proposition, and bear in mind that these 4 types of proposition are the only proposition types that we'll be dealing with in chapters 5 and 6. So it's a pretty robust system built out of 4 types of sentence. What are they? Well, there is the universal affirmative proposition, the universal negative proposition, the particular affirmative proposition, and the particular negative proposition. Here are some examples that go with, respectively, the universal affirmative, universal negative, particular affirmative, and particular negative. Dolphins look like they're smiling. What are we talking about? All dolphins. We're talking about the group of dolphins, and we're talking about things that look like they're smiling. None of the directions make sense. We're talking about every single one of the directions and things that make sense, and we're rejecting that this is the case. In other words, we're rejecting the connection between directions and things that make sense. Quite a few students are intrigued by logic. We're talking about at least one student and the group of things that are intrigued by logic. And then lastly, lots of dogs are unfriendly. We're talking about at least one thing that's a dog and that is not friendly. So notice as I broke each of the sentences down, we have a quantity, right? Universal, everything in a class, or particular, at least one thing in a class. And the things in the class are related to another class, affirmatively or negatively. So here's how the categorical proposition is defined. A categorical proposition is a proposition that relates two classes of objects. In the example in blue, we have the class of stand-up comedians and we have the class of witty persons. The class is the group of objects. You'll also refer to class as group or category of thing. They all mean the same thing. And in this case, again in blue, all stand-up comedians are witty persons. We have the two classes related to each other by way of the universal affirmative, which is expressed by all. That's the quantity. Take a look too at the name of each of the classes in a proposition of the categorical variety. The grammatical subject of a categorical proposition is called the subject term. The grammatical predicate of the categorical proposition is called the predicate term. So the subject term is the reference for the class of things about which we say something, in this case, stand-up comedians being witty persons. Notice also that there's more language that relates these two classes together. We have the conjugation of the verb to be, which in this case is are for the plural of is. And this is known as the copula, and it is what separates out one class from another, so we know which two classes we're dealing with. In addition, this sentence is written in what's called standard form. That is, you have a quantifier, all, and you have a noun or a noun phrase for respectively the subject term and the predicate term. So the subject term and the predicate term will always be classes of things, and so need to be reflected grammatically as a noun or a noun phrase. And then we have the copula. As I mentioned, there are 4 types of categorical proposition, and you'll notice that next to each of the blue sentences to the left of the blue proposition is a letter, A, I, E, and O. These are letters that are given arbitrarily, effectively, to the 4 types of proposition. So you'll read and hear about an A claim or an A proposition, and that's just shorthand for the proposition all S are P, where S is subject term, P is predicate term. So an A claim is a universal affirmative, an I claim is a particular affirmative, an E claim is a universal negative, an O claim is a particular negative. And what we want to do, part of what we want to do, is talk about the logical structure of each of these proposition types. We want to do this because we're going to want to make inferences from one proposition type to another, or from a couple of propositions to a third. That latter is Chapter 6 material. So the way that you might be interested in remembering the AIEO is, or you could say AEIO if you want to go in alphabetical order, is by this little chart with the Aristotle. Some of you may find it useful, some of you may not. I am kind of ambivalent about it, but if it works for you, awesome. So what I'll do from now on is speak interchangeably about A propositions and universal affirmative, O propositions and particular negative, and so forth. Okay, so the universal affirmative is a claim that refers to the entirety of the subject class in a positive relationship to the predicate class. So what we're saying is that every member of the subject class is a member also of the predicate class. If you will, the predicate class is big enough to absorb every member of the subject class. So the claim, all cell phones are expensive toys, tells us that every member of the cell phones class is a member of the expensive toys class. The universal negative also talks about the entirety of the subject class, but it also talks about the entirety of the predicate class to the extent that these two classes are mutually exclusive of each other. Wherever you find a cell phone, you won't find an expensive toy, and vice versa. So the E proposition claims that no members of the subject class are members of the predicate class. And what we can infer from there, remember this, by the way, when we get to conversion, is that the converse is also the case. Let's back up just a sec. It's clear enough, I think, to say that all cell phones are expensive toys tells us that the entirety of the cell phones class is a member of the expensive toys class, but not vice versa. Consider this example. All horses are equines, but we wouldn't say that all equines are horses. There are zebras and donkeys and mules. We could say all Toyotas are vehicles, but not all vehicles are Toyotas. So we can't swap places of the subject and predicate class with a universal affirmative and get a correct statement, or if you will, draw a valid inference. But you can do that with the universal negative. Next, the particular affirmative, just like the particular negative, is a much more restricted claim. If you will, the domain of discourse here is much narrower. What I mean by that is this. When we say some SRP, we're saying there is at least one member of the subject class that's a member of the predicate class, but we don't know about the other members of the subject class. In other words, we're not saying all, we're saying at least one. Lastly, the particular negative is a proposition that tells us that there is at least one member of the subject class that is excluded from the predicate class. There is at least one cell phone that is not an expensive toy. All right, let's see how we're doing. Some political documentaries are shows deserving of acclaim. First, ask yourself, is this an A, an E, an I, or an O claim? Alternatively, you can ask yourself, is this a universal affirmative, a universal negative, a particular affirmative, or a particular negative? The answer is, it is an I proposition. It's a particular affirmative. The subject class is political documentaries. The predicate class is shows deserving of acclaim. Both are nouns or nouns phrases. Now let's talk about three concepts that we're going to be using for the entirety of our work in both Chapter 5 and Chapter 6. So I'm not going to necessarily ask you to define these concepts, except for perhaps in the reading quiz, but you're going to be using them. The only concept that might feel a little tricky at first is the concept of distribution, but if it doesn't hit home with you in Chapter 5, it most definitely will in Chapter 6, because we'll be using it in a way that I think might resonate with you more than is the case in Chapter 5. But again, I don't know, you might be comfortable with it right from the beginning. Okay, so quantity. Quantity is the how much. Are we talking about universal, everything, or are we talking about particular, at least one? The quality of the claim is its affirmative or negative status. So every categorical claim reflects a quantity and a quality, the how much and in what way. Now, distribution is a concept that has to do with how much of a class is included in or excluded from another class. So let's talk a little bit more about this. When we're talking about distribution, we're talking about the entirety of a class. So just a moment ago, I said we ask how much, right? When we say that a class is distributed, we're saying that the entirety of the class falls into or is a member of another class, or we say that the entirety of a class excludes from itself at least one member of another class. So bear with me and I'll see if I can help make some more sense of this. First, let's talk about the quantifier and the quality. When we are talking about quantities, we're talking about the quantifier specified by the terms all, no, and some. When we're talking about the quality, we're already talking about quantity, and then we're talking about either affirmative or negative. Our copula is going to tell us about the relationship between the two classes, in the sense that the copula specifies the two classes or helps us to distinguish them. So now let's return to distribution. When you think about it this way, when you walk into a classroom and you sit down and the syllabus is distributed, it should be the case that there are enough syllabi for every person in the class, and that when the last of the syllabi is given out, each person has one. That's the categorical logic way of thinking about distribution. The entirety of the syllabi are distributed in among the class members. When the entirety of a class is not distributed, it's either not entirely included in or does not entirely exclude from itself another member or the entirety of another class, then we say that that proposition does not distribute the class in question. Let's take a look at some examples. In an A proposition, we're talking about the entirety of the class cats distributed into the class of mammals. Remember earlier we said that every member of the cat class is a member of the mammals class. Well, at the time we were talking about cell phones and expensive toys, but you get the idea, right? The entirety of the subject class is a member of the predicate class. But remember, we also said that you can't go the other way. In other words, when you're talking about an affirmative universal, you're talking only about the cats class in relation to the mammals. We don't know about the mammals class in relation to the cats class. So what we can't say is that the mammals class is distributed. When you have an E proposition, on the other hand, notice in bold, both classes, the turtles and the mammals, are distributed. And that's because we said that the entirety of the turtle class is excluded from the mammal class, and the entirety of the mammal class is excluded from the turtle class. So both the subject and the predicate terms are distributed in the E proposition. Now again, remember, we're laying out concepts, we're laying out technical terminology. We're not yet using it in a way that might be meaningful for you. But what you might do is remember the distribution rules. And then as we're working further in the chapter, and again, like I said earlier, especially in chapter 6, you're going to find that the concept of distribution makes increasingly more sense. Now, of all four propositions, only the I proposition does not distribute anything. In other words, the subject and predicate classes both don't distribute. their members. That's because we're saying there is at least one. So when we say some students are sophomores, we're saying at least one student is a sophomore. And we can also make the reverse claim. We can convert it. Some sophomores are students. But since we don't know about the entirety of either class, we say that each class is not distributed or is undistributed in an I proposition. Lastly, the O proposition, and this might feel a little tricky. A lot of people find this perplexing, but the O proposition distributes the predicate class. Why? We're saying that there is at least one car, so not the entirety of the car class, but there is at least one car from which the entire class of fuel-efficient vehicles is excluded. So the entirety of the fuel-efficient vehicles class excludes at least one member. Here are a couple of shorthand ways for you to think about the distribution rules. Take a look on the left side first, the left column. Notice that there are two superscripts, D and U. D stands for distributed, U stands for undistributed. So for the universal affirmative, we have the subject class distributed, the predicate class undistributed. Notice that the powerhouse proposition is the universal negative because it distributes both classes, subject and predicate. The I proposition doesn't distribute either class, and the particular negative, the O proposition, distributes only the predicate class. Another way you can think about the distribution rules is as follows. Universals, A and E, distribute the subject class. Negatives, E and O, distribute the predicate class. All right, let's talk about quantity, quality, and distribution. Some protein supplements are not healthy diet aids. What type of claim is this? A, E, I, or O? Some protein supplements are not healthy diet aids. That's an O claim. What do we know about O claims? The predicate class is distributed, the subject class is not. What is the quantity? Particular. Quality? Negative. So now we're ready to start doing something with these propositions. Remember, we have 4 proposition types, and one of the questions that we want to ask is what valid inferences we can make from one proposition to another. For example, what necessary inferences are there from, say, an A claim to an E claim, or an I claim to an O claim, and so forth. The way that we show how these inferences are possible is through the square of opposition. There are 4 types of inference we can make. We can talk about propositions as contradictories, contraries, subcontraries, and subalterns. The basic idea here is for us to get a pretty good handle on what the logical structure of these proposition types allows us to say when we want to make an inference, for example, from some to some are not, or let's say from no to all. Now, there are going to be some restrictions on the sorts of inferences that we can make, and these restrictions are specific to Aristotle's system. And I hope that by the time we get through this, you'll understand why these restrictions exist. You'll also be very clear on the fact that these restrictions complicate things quite a bit. And in seeing that, we should see why it is that the modern square of opposition offers us a very different interpretation than the traditional or Aristotelian, insofar as the scope of the inferences is much smaller. So let's get started and see how these animals work. First, we talk about propositions as contradictories when we say that if one is true, if some proposition is true, its contradictory must be false. In other words, contradictory claims can't be true at the same time, but they also can't be false at the same time. I mean, think about it this way. If I say, today is Monday, and today is not Monday, I'm asserting two contradictory claims. I'm asserting, more specifically, that the sentence, today is Monday, is true. I'm also asserting the sentence, today is not Monday, is true. But that can't be. If one is true, the other has to be false, and vice versa. So also with the following sets of propositions. A and O propositions are contradictories. When an A proposition is true, the O proposition must be false. On the other hand, if the O proposition is true, the A must be false. We can come up with a whole slew of examples that will make sense in terms of their content, but what we want to really get at eventually is why this is the case from the standpoint of the logical structure of the sentences. So we'll get there shortly. Similarly, E and I propositions are contradictories. When the E claim is true, the I claim is false. When the I claim is true, the E claim is false. They can't be true at the same time. They can't be false at the same time. If I say all dogs are canines, and I say that's true, it can't be true that there is at least one dog that's not a canine. On the other hand, if I say there is at least one apple in the barrel that's not ripe, I can't maintain that all the apples in the barrel are ripe. So I think you see how this is going in terms of content that makes sense to us. But again, what we're going to want to do is to try to understand what the structure of the sentence is that makes these contradictories. So we'll push on that a bit more shortly. First, here is a box, a square, that gives you a view of typically how the claim types are laid out. In fact, you open up any logic textbook anywhere and this is what you're going to find. A in the upper left, E in the upper right, O in the lower right, I in the lower left. And the two arrows there, the two two-way arrows tell us that the inferences go both ways. In other words, what we have is a universal affirmative that can't be true while the particular negative is, and vice versa. So let's talk a little bit now about how it is that these structures are what make the contradictories. In other words, why aren't E and O contradictories? Why aren't A and E contradictories? That's a question. Well, we'll find out the answer to that latter question when we talk about contraries. But what we get with contradictories is the following. The quantity and the quality of the claim, whether it's A, E, I, or O, is what tells us whether or not that sentence can be true while another sentence is claimed to be true. So when we think about the fact that the universal affirmative distributes the subject class, the entirety of the subject class is in the predicate class, or the entirety of the subject class's members are also members of the predicate class, we can see how that can't hold if the particular negative is true. Why? Because the particular negative rejects at least one member, the particular negative's predicate rejects at least one member of the subject class. Similarly, when you look at the E proposition versus the E proposition says that S and P are mutually exclusive. If no S are P, that means that there's not even one S that's a P. Oh, look, I've just denied the I claim in asserting that structure of the E claim. So contradictories are really important to know, if for no other reason than they are different animals from, respectively, contraries and subcontraries. And subcontraries and contraries tend to sort of trip us up a little bit because they force us to think about some flawed inferences that we often make. All right, so contraries are the universal affirmative and universal negative claims, right? And they are specifically propositions that can't be true at the same time. In other words, if the A proposition is true, the E is false. If the E is true, the A is false. Notice what I'm saying. I'm saying you have to know what the originating proposition is in order to draw the relevant and accurate inference. So when we say both can't be true at the same time, we have to know what the premise proposition is. All right, let's take a look at some examples. Remember, we're using the examples to help you understand the inference that is legitimate and the inference that depends on content. But what we want to see eventually is that these inferences have to do with the structure of the sentence in question, so that when you're looking at, for example, a universal affirmative, you know that it is the structure of that sentence, when true, that forces the false universal negative, and vice versa. When the universal negative is true, the structure of that sentence forces the falsity of the universal affirmative. So take a look at the four sets of examples in blue. In the at the top left corner, you'll see no squares are circles, all squares are circles. Move your eyes to the right and you'll see all guitars are stringed instruments, no guitars are stringed instruments. And these are examples of the inference from a true universal, negative or affirmative, to a false universal, affirmative or negative. So whenever you start with a true universal, its contrary must be false. On the other hand, drop your eyes down to the bottom two sets of examples, and you'll notice that starting with a false universal doesn't yield you necessarily a true or a false contrary. All animals are dogs is false. No animals are dogs is also false. No dogs are animals is false. All dogs are animals is true. So starting from a false universal doesn't tell you anything about the value of the contrary. Remember, however, starting with a true universal tells you that the contrary must be false. Now remember I said earlier that the contraries and subcontraries, as well as subalternation rules and superalternation rules, are such that in Aristotle's system you have to know what you're starting with in order to know what inference you can make. When we look at the modern system, there's a real effort to divest ourselves entirely from content, in the sense that we don't need to know the truth value of the originating sentence. So we'll get to more of that later. So contraries, again, pairs of propositions of the universal variety such that both can't be true at the same time, but they both can be false. Subcontraries make a similar move, except the values are different. In other words, both can't be false, but both can be true. What are subcontraries? Those are inferences from I to O and O to I. And I think that this is particularly useful to us because, as I mentioned before, we oftentimes think that we can make an inference from a particular affirmative to a particular negative and vice versa, when in fact that inference isn't guaranteed. So here are a couple of sets of examples. Some coins are pennies, that's true. Some coins are not pennies, that's also true. Some oranges are not citrus fruits, that's false. Some oranges are citrus fruits, that's true. So what you want to think about is this: when you start with a true I proposition, the inference to the O proposition is what's known as undetermined. It's just like when we start with a false universal, the contrary's truth value is undetermined. Could be true, could be false, we just don't know. It depends on the sentence, not on the structure of the truth or falsity depends not on the structure of the proposition. On the other hand, if you begin with a false subcontrary, then the inference to its opposite, if you will, must be true. Lastly, let's talk about subalternation. Now, you have two universals, those are known as the superalterns, and you have two particulars, those are known as the subalterns. And when we move from a universal to a corresponding particular, and by corresponding I mean a particular that has the same quality, you can, in Aristotle's square of opposition, draw a necessary inference. And I'll say something about what that means in a moment in terms of why it's the case. But for right now, just know that if an A claim is true, the I claim is also true. If the A claim is false, on the other hand, the I is undetermined. The same thing goes for the E to O inferences. What you can't, so you can move down, right, from A down to I and from E down to O. But what you can't do is draw an inference from the particular to the corresponding universal. And this makes perfectly good sense when we think about things like what we call stereotyping. Just because, for example, one person in a group has certain characteristics, that doesn't mean the entire group does also have those characteristics. We want to avoid that sort of reasoning. So let's look at some examples. If it's true that all musical instruments are difficult things to master, then it's true that there is at least one musical instrument that's difficult to master. Similarly, if it's true that no musical instruments are difficult things to master, it's also true that some musical instruments are not difficult things to master. All right, let's take a breath here because you have had a lot thrown at you and it's really easy to kind of get lost in terms of what everything means. But I do think, if I am any indication, that repeated practice does eventually lead to not only knowing that, but knowing why the square works the way that it does. So recall, this is a skills-based course, so the only way to really begin to understand the concepts and make sense of the sorts of inferences that we're talking about is to practice, 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 and then practice some more. So here's a chart which is taken from the text where we understand the square of opposition. Let's start with contradictories. Those bad boys are such that whenever One claim is true, its contradictory must be false, and vice versa. So A and O can't be true at the same time, can't be false at the same time. E and I can't be true at the same time, can't be false at the same time. Contraries are inferable, if you will, in terms of they're determined if and only if you know the starting point of the inference. In other words, if you know that the premise is true. So if the E is true, the A must be false. If the A is true, the E must be false. But you don't know anything about the inference. In other words, the truth value is undetermined when you start with, when your premise is a false A or a false E. So a false A could yield a true E, could yield a false E. We just don't know, and vice versa. Similarly, though starting with different values, subcontraries require that you know that your premise is false. Subcontraries can't both be false at the same time, but they can both be true. So if you start with a false O, the I must be true. But if you start with a true O, the I is undetermined. Lastly, notice with respect to subalternation that truth flows downward. Falsity, on the other hand, flows upward. When we make an inference from one categorical proposition to another, we make what are known as immediate inferences. An immediate inference or an immediate argument is an inference that has but one premise. So the square of opposition is one such way in which we can make immediate inferences. So, for example, if we have the premise, all elected politicians are people who serve a term in office, we may conclude by the square of opposition that some elected politicians are people who serve a term of office. And for each of these propositions, we have a truth value of true. A true A proposition on the square of opposition yields a true I proposition, which is the subaltern of the A. Take a look at the second example. Notice that we're trying to move from one universal to its contrary. And the problem here, as we know, is that the universal, that is the premise, the E proposition, is false. Consequently, we cannot determine the value of the contrary, the A proposition. Why is that the case? Well, we saw a couple of examples where starting with a false universal can sometimes yield a false universal as well, and sometimes can yield a true universal. And since the truth and the falsity is not guaranteed, in other words, unlike when you begin with a true universal, you must yield a false contrary. When you begin with a false contrary, you don't have a determined inference. So one of the nice things I think about working with these immediate inferences, and we'll learn some more, is that we become much more careful about the way we think of our quantified claims, our categorical propositions, and what it is that we're doing when we draw an inference from one to another. I mentioned before that we oftentimes want to draw an inference from an O to an I or an I to an O without really stopping to think about whether or not that inference is allowed on the square of opposition. In other words, simply taking an O claim and inferring an I claim, it's subcontrary from it, is not sufficient. What we need to know is that as far as subcontraries go, that the premise, in this case the O claim, is false, so that we then know that its subcontrary is true. But recall, if we start with a true O claim, the I claim, the subcontrary, is undetermined. Okay, let's practice one concept and one skill. The concept is the subcontrary on the square of opposition, and the skill is the skill is applying your understanding of drawing an immediate inference from one subcontrary to another. So we have some columnists are coffee drinkers. That's an I claim. If we assume that the I claim is true, the question is whether or not its subcontrary must also be true or must be false. First, though, what's the subcontrary? All right, the answer is C. My next question to you is whether or not the subcontrary, that is the answer choice C, the O claim, is necessarily true or false. And the answer is it is undetermined. So now let's focus on that skill. Let's take the following claim. Some physicians are not good communicators. That is an O claim, and we're told if it is true, then the proposition no physicians are good communicators, that's an E claim, is true, false, or undetermined. So think back to the square of opposition. Is it the case that either truth or falsity flows upward from an O claim to its superaltern, in this case the E claim? And the answer is it's undetermined. Remember that when you have an I claim, truth does not flow upward to the superaltern. When you have an O claim, the truth of that claim does not flow upward to its superaltern. And do you recall that I mentioned a way that you can think about this? You can think in terms of the mistake we make when we infer from a couple of instances in a group to the entirety of a group. So for example, just because it's true that some dogs are not pit bulls, it does not follow that no dogs are pit bulls. Hence, answer choice C. We're going to move on now to other immediate inferences, but before we do that, make sure that you are comfortable with the chart on page 177. It's figure 5.2, and that's the square of opposition chart. And if that doesn't work for you in terms of having a visual of what inferences you can make, largely because in the case of the contraries and the subcontraries, you don't have a beginning point, right? So you don't, if you haven't already understood or memorized that contraries are determined inferences when and only when the premise is true, and subcontraries provide determined inferences when and only when the premise is false, then there will be another way for you to think about the square of opposition, and that will occur in a follow-up video where we're going to spend a lot of time practicing. Meanwhile, though, let's move on to talk about 3 more inferences that you can make, and these inferences have to do with manipulating a proposition as opposed to keeping the proposition's elements intact and moving from one claim type to another. For example, the A to the O. In conversion, obversion, and contraposition, we have immediate inferences that are determined or not, as far as validity goes, by how the proposition is manipulated internally. So let's see how that works. First off, I know there's a lot to look at on this slide, but let's just start with the concept of conversion. When you convert a proposition, whether the resulting inference is true, the process that you use is simply swapping the subject and predicate terms. So when you convert an A proposition, all S or P, you maintain the A proposition's status as a universal affirmative, and all you do is swap the subject and predicate position. So take, for example, the proposition, all dogs are animals. If you convert it, you get all animals are dogs. Now, the A proposition premise, all dogs are animals, is true, but you can't infer that the converse is true. And we can tell that by any number of examples that we use, but what we really want to understand, and we'll talk about further, is how the logical structure of the universal affirmative proposition disallows conversion. But let's start by talking about what you can convert validly. So E and I propositions can be converted validly. Just as a quick heads up, think about it this way. Conversion is an inference that's valid for E and I propositions. And then there's a parallel method of converting A and O propositions, and that's called contraposition. And it's a little bit more involved than conversion is. Conversion's pretty intuitive. So when you convert an E proposition, you swap the subject and predicate places, and the resulting statement is true. So if you say, no dogs are rabbits, and then you infer from that, therefore no rabbits are dogs, you've drawn a valid inference. And this has to do with the nature of the E proposition. More specifically, let's go back to that concept of distribution that we talked about earlier. The entirety of the subject class is excluded from the entirety of the predicate class. Or another way to say this is the predicate class is distributed insofar as the entirety of the predicate class disallows the subject class from it. And vice versa. The entirety of the subject class disallows the entirety of the predicate class. So what you have is the following. There's not even one member of the subject class that's a member of the predicate class, let alone all members. So you can say all members of the subject class are not members of the predicate class, and vice versa. That's where you get conversion. Now, the I proposition, as you know, is one that does not distribute either the subject class or the predicate class. But think about the semantics of saying that there is at least one member of the subject class that is also a member of the predicate class. And when you do that, you can begin to see that there is a relationship between the two classes that's reciprocal. If I say there is at least one dog that is an animal, we can also say, therefore, there is at least one animal that is a dog. Now let's take a look at how you can make a move known as conversion by limitation for the A proposition. Since you can, on the square of opposition, infer the I proposition from the A proposition, in order to convert the A proposition, you first limit the scope of the quantifier. So you move from A to I, and then you convert the I. Note, though, that conversion doesn't work at all. There's no limitation. There's no sort of extra move you can make with the O proposition to make that immediate inference valid from one O to its converse. Obversion allows you to make specific inferences using each of the 4 claim types. So obversion is valid for all 4 claim types. Here you have a 2-part process. First, you change the quality of the proposition. So if you begin with an affirmative claim, you change the claim quality to negative. So an A becomes an E, an I becomes an O. Notice you're not changing the quantity, you're changing just the quality. The second thing you do, the second move you make, is to replace the predicate term with its complement. The complement of a term is everything that is not that term, or everything that is not that category. And we specify that notness, if you will, with the prefix non. So take a look at the example where we have a universal affirmative, all carrots are vegetables. Notice that we leave the carrots and the vegetables positions, the subject and predicate positions, alone, and we change the quality from affirmative to negative. That means we're also leaving the quantity alone. So universal affirmative becomes universal negative. And then we add the predicate, we add the complement to the predicate. Another way you can think about this, which may not seem as intuitive, which is why I use the language I used, but maybe the language I used isn't very intuitive for you, in which case you can think about it this way. What you do is you replace the predicate term with its complement. So we end up with no carrots are non-vegetables. Now you might find yourself wanting not to have these multiple negatives. The mind tends to want to make the affirmative where we have this resulting E claim, right? Where we take the obverse of the A claim, we end up with no carrots or non-vegetables. We feel like, no, we really want to say the affirmative. But that mental feeling should just reinforce the idea that the A and the E claims allow for these valid inferences when we follow the process of obversion. So pause for a moment and take a look at each of the remaining inferences from I to O and O to I and from E to A. Lastly, contraposition is, as I mentioned before, the parallel inference to conversion. Contraposition allows us to do for A and O claims directly what conversion allows us to do for E and I claims, and then allows us indirectly or by way of a first step for the A claim. So recall that when we convert any claim, we swap the subject and predicate terms. And when we convert an I claim, we swap the subject and predicate terms. When we take conversion by limitation of the A claim, we first infer from the A to the I, and then we again swap the subject and predicate terms. We can do the same move for the E claim in contraposition that we did for the A claim in conversion. Namely, there's contraposition by limitation for the E claim. But first, let's talk about what it means to take the contrapositive of a claim. What we do is we take the A claim, in this case, if you're looking at the example, all S or P, and we swap the subject and predicate places with, and replace them, I should say, with their complements. Now, I recognize that it's probably the case you find the resulting claim, the contrapositive, to be a bit of a mouthful. And it's true, it is. In fact, if you think that is a mouthful, think about the contrapositive for an O proposition, some S are not P. What you're going to get is some non-P are not non-S. Yikes, that's a lot. But bear with me because, like I said, we're going to practice with these moves. And again, I think that the sort of intellectual stretchiness and discipline that you get with this sort of work is good for all sorts of reading and analytical activities. But it's also great as a discipline of making ourselves more attentive to the structure of our propositions. Okay, so let's take a look at how we make the contraposition of the E-claim. So we take the E-claim, in this case, no gorillas are lions, and we first move downward, if we're thinking about the square of opposition, to the E-claim's subaltern, which is the O-claim, and we get some gorillas are not lions, right? If it's true that no gorillas are lions, then it's true that at least one gorilla is not a lion. The contrapositive then becomes this: some non-lions are not non-gorillas. Now, similarly to conversion, which just isn't valid for O claims, contraposition just isn't valid for I claims. So you can convert an A claim by limitation, you can contrapose an E claim by limitation, but you can't convert an O and you can't contrapose an I, at least not validly. I mean, when I say you can't do it, I don't mean that you can't physically write out the contraposition of an I claim. It's just that the inference won't be valid. Okay, let's practice a little bit before moving on. We have the following proposition: some martial arts teachers are not tournament winners. What sort of claim is this? It is a particular negative. That's an O claim. The subject class is martial arts teachers, and the predicate class is tournament winners. Question for you: what is the converse of this claim? Next question for you: can we convert an O claim validly? Next question: what is the obverse of the O claim? Do you remember also that obversion is valid for all four claim types? Lastly, what is the contraposition of the O claim? The converse is some tournament winners are not martial arts teachers. Remember, the converse is not valid for O claims. The obverse is some martial arts teachers are non-tournament winners. And the contrapositive is some non-tournament winners are not non-martial arts teachers. And remember, conversion is not valid for O propositions. Now, so far, we've been talking about universal claims as if there are, in fact, members of the subject class. So, for example, we've talked about universal affirmative claims distributing the subject class as if there are, in fact, members of the subject class to be distributed into the predicate class. But that's not actually always the case. Take, for example, the claim, all unicorns are mammals. Or take the claim, all leprechauns are greedy. Or take the claim, all fairies are lovers of pixie dust, etc., etc. When there are no members of the subject class, we would say, strictly speaking, that those claims as a whole, those propositions as a whole, are false, right? So think about it this way. Going back to what we said originally that Aristotle is interested in doing, namely taking a look around him and trying to learn about the nature of things, he's not going to be very interested in talking about non-existent things. In other words, he wants to say, if we're going to make a universal affirmative claim, then we're assuming that there is, in fact, a member, at least one member of the subject class in question. And this makes sense, too, if you think about the way that we go about observing, right? So how do we make generalized claims like all dogs are animals? Well, we come to a point where we've investigated enough of these four-legged, padded, hairy creatures that go boof, 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 and such that we can say that they all fall into the class of dogs. And then we've identified enough features of animals to be able to say that the dogs fall into the animals class. But notice that I started with this investigating these creatures, right? So there's a four-legged, padded, footed, coated, hairy-coated creature that goes woof, woof, woof. And then we get to the point where we say that every creature of this sort is a dog, right? And then we can say eventually all these dogs are animals. So when we're making the universal claim, we do so on the assumption that there is at least one member of the subject class. And when we make this assumption, we make the move that's called existential import. In other words, we say that the subject class has actual members. So existential import is what we say about any universal claims subject class when we say that there is in fact at least one member of that subject class. But we're going to find that we don't have to make this assumption. Okay, so let's make some sense of what you're looking at here. When we take the Aristotelian approach to universal claims, we assume existential import. That's the move that we make. That's the standard approach. But there is another interpretation that I mentioned just a moment ago of the universal claim, which does not assume existential import. In fact, the modern interpretation suspends judgment about whether or not there are any members of the subject class. And this suspension of judgment has some rather significant consequences for the immediate inferences that we can make. It severely restricts them. So more about that in a moment. The reason why the modern interpretation suspends judgment about whether or not there are any members of the subject class in a universal claim is because we want, or they want, we following the modern interpretation, want to make inferences without having to know first whether or not the premise is true. So recall that when we take the contrary of a universal claim, we can't determine the truth or falsity of the inference when we know that the premise is false. And in order to determine the inference as false, we have to know that the premise is true. On the modern interpretation of the universal claim, that is eliminated for us. We simply take the following approach. We assume that the premise is true, and then we ask what must be the case as an inference. And so we're limited, as I mentioned before, to actually just one inference type on the square of opposition. Now, take a look at the bottom of the slide before we move forward, and you see those two overlapping circles. The one on the left represents the subject class and the one on the right represents the predicate class. And the numbers will tell you about what area of the subject or predicate class is referred to when we begin to diagram, which we're going to do very shortly. So number one is the area of S that's outside of P. Two is the area where S and P overlap. Three is the area of P outside of S. And four is that area that's outside of S and P altogether. So you can think of the numbers as helping us understand the domains of discourse in a given proposition. Now, take a look at what we're left with when we eliminate the assumption of existential import. We're left with contradictories. We're left with saying, okay, on the assumption that the A proposition is true, the O must be false. On the assumption that the O proposition is true, the A must be false. In other words, think about validity once again. The concept of validity says that the premises, if assumed true, if taken as true, premises are what we suppose, are what we accept, or what we take as true, then the conclusion is thereby guaranteed when the argument is valid, right? Or we can't make the conclusion false when the premises are true. So what we do with the contradictories is we say that we don't need to know what the truth value of A is or O is. We know that they can't both be true at the same time, can't both be false at the same time. And that's the only immediate inference on the square of opposition that allows us to suspend any kind of judgment about what the values are of each of these claim types. So now let's talk about what you're looking at when you begin to diagram each claim type. So what you need to understand, and we're going to practice with this more, but as you're being introduced to these concepts and skills, we're first just going to talk about them and then we'll work with them. You're seeing in blue shading for the upper left and upper right claims. Shading is what we do when we are diagramming universal claims. So shading on the left, upper left is in area 1. That's the area of S outside of P. Shading designates or represents emptiness. So when we say all S are P, and we shade the area of S that's outside of P, or area 1, we're saying that whatever S's there may be, and we're not saying there are any, they're all members of the P class. Now take a look at the E proposition. No S or P. Shading designates emptiness, remember? So what we're saying here is that the area of overlap, that's area 2, is empty. There's nothing there. You can't put anything there. Now cast your eye diagonally to your left and down to the I claim. Notice that the I claim directly contradicts the E claim. Take a look at the X. The X designates the existence of at least one thing. So in the I claim, we have the following. There is something, the thing is an S, and it's a P. That means if the S claim is true, the E claim can't be true because the E claim says that that area of overlap is empty. Now cast your eyes over to the O claim. The O claim says there is at least one S that's not a P. So we put the X in area 1. That's the area of S that's outside of P. Notice if you cast your eye diagonally to the upper left, that if the A claim is true, there can't be an X in the area of S that's outside of P. There can't be an area, or sorry, there can't be an X in area 1. So I hope you can see by way of this diagramming of propositions how contradictories look. So what we get when we Venn diagram our propositions is we get a visual representation of these propositions' logical structures. Okay, so we just finished talking about Chapter 5, Sections A through F. What we covered here is an introduction to categorical logic by way of building from categorical propositions to immediate inferences, namely those inferences that we make on the square of opposition, as well as further inferences implied by the square of opposition, specifically conversion, obversion, and contraposition. Now, there's a lot that you might feel like you're juggling right now, but remember what we're doing. We're taking time to look at the beginnings of a system of logic. Now, what Aristotle's doing here is allowing us to narrow our focus in terms of the types of sentences that we work with. We already know that for us to have an argument, for us to make inferences, we need to start with sentences that are true or false. But there are all sorts of sentences out there. You can say things like, Julio loves Alma. You can say things like, if Julio loves Alma, then Alma and Greg are friends. And you might wonder, well, how does that follow, et cetera, et cetera. You can make sentences like, today is Wednesday, and I study logic on Mondays, Wednesdays, and Fridays. So since today is Wednesday and I study logic on Mondays, Wednesdays, and Fridays, I study logic today, and so forth. But what Aristotle allows us to do is to kind of narrow what feels like an infinite variety of sentence types to a scope that covers just 4 sentence types. So it's kind of cool that you can take any sentence that's true or false and you can convert it, or you can translate it, transform it into a sentence that is of the categorical proposition variety. That is, it's an A, E, I, or O proposition. And so as we're narrowing our focus and we're learning this system that allows us to study the structure of a narrow set of propositions, the logical structure of those propositions, and then how those propositions allow or don't allow certain inferences. And then moreover, when we study an adjustment to the way that we think about the universal subject class, the subject class in a universal claim, then what we begin to do is to see a little bit more clearly how important it is for us to be careful about the way that we reason, because even in this very limited study, there's a fair amount for us to be able to do. Now, I mentioned before that we are going to be studying 2 systems of formal logic. This is one. And in the rest of Chapter 5, we're going to look further at immediate inferences. Then we're going to move into Chapter 6, where the study is, where the focus of study is on the categorical syllogism, which is a specific type of argument. So I hope that you're going to find by the time we're done with Chapter 5 and Chapter 6 that you have a nice organized way of thinking about your language. And that is learned by studying the categorical system that Aristotle developed, and then the I don't know if you want to call it improvement, but the development of categorical logic in the modern system. Okay, so before we move into the remaining sections of Chapter 5, however, we're going to spend some time practicing. So that is our next video.